Today, we're going to talk about starting a 3D printing service for high-temp materials and why it's vastly important that you get the right information from the client before you even start slicing. If you're starting a 3D printing service in 2025, you definitely need to be doing high-temperature materials on something like our 22 IDEX here. We've been running a high-temperature printing service for nearly 10 years, and this video is going to detail everything we've learned that we need to find out from the client before we even start slicing. These are important factors to consider, especially when you're dealing with aerospace, medical, automotive, or other industry customers who need a part for their business. You need to make sure that you're doing it properly, and a lot of people just think a 3D print is a 3D print. So you have to set expectations, and you have to get a lot of questions answered about the part. Where's the part gonna live? What shape is it? What does it look like? This is the stuff that we ask our clients in our high-temp 3D printing service that we've been doing for nearly 10 years. So this is designed to fast-track you to having success printing high-temp parts for business. So, maybe you submitted a part to our 3D printing service at visionminer.com/print. We specialize in high-temperature materials like ULTEM, PPSU, PEEK, PAEK, PEC, many high-temperature thermoplastics in FDM 3D printing. And we do also do SLS and SLA, but primarily our specialty is in FDM. That's diffused filament fabrication. We get a lot of requests that send a part and say, we want it in PEEK. And we're like, great, why do you want it in PEEK? And they're like, well, it's the best, right? And we're like, okay, let's talk about the application, what stresses it's gonna see, and what it really needs to do and resist in order to work. And then a lot of the times we'll find there's a cheaper or easier or even more robust material that could be used instead of whatever was requested. So getting into the details, let's go into what the important things are. So category 1 is thermal resistance. Makes sense, we're a high-temp 3D printing company. So now this can actually go in both directions, high temperature resistance and also low temp resistance. For example, cryochambers, liquid nitrogen, high altitude drones are going into space. Those are all low temperature resistance. High temperature generally is like ovens or wave soldering production lines, or maybe it's going into an engine bay where there's going to be a lot of heat and it needs to resist that. Or maybe it's solar panels and it's going to be in the sun in the middle of Arizona all summer long and it needs to survive those environments. So thermal resistance is a big one. We need to know how hot is the environment going to get, how long is it going to be in that environment, and are there any other factors to consider? For example, with molds, a lot of the times we'll see that, hey, well, it's going to be up to this temperature, but only for 30 seconds, and then it's going to come down. But we need to cycle that, hundreds, if not thousands of times in this one mold. And maybe it's a carbon fiber composite mold that's going into an autoclave to get cured, and it needs to do that over and over and over. So that's the other thing to consider, is how many times do you need it to do that? Maybe if it's just a 1 or 2 shot, or maybe 10 shot mold, you don't need it to be at a peak that'll last for thousands of runs. It could be done in high-temp carbon fiber nylon or PPSU or something cheaper and easier to produce. Category 2 is going to be chemical resistance. We've got the thermals, but the chemicals. What kind of environment is this going in? For the automotive guys out there, we get a lot of parts that obviously need to resist oil and hydrocarbons and gasoline and things like that in addition to the temperature. But we also see like laboratory environments where it's like, yeah, it needs to hold up to sulfuric and hydrofluoric acid for 24 hours or for 3 years or things like that. A lot of times we'll see radiation, especially in like nuclear facilities that love to use PEEK for stuff. We see a lot of different chemical and environmental stresses that are important to note, because God, I can go way back. Years ago when we first started here, a customer requested PPSU, and I was printing on the old FunMat HT. This is way back in the day. This is like 2017. And I remember I was trying to get this part to work for like 3 or 4 days. I was sleeping in the office, and I kept trying to print it, and it kept peeling up. This was before we made our nanopolymer adhesive bed adhesive. This is when we were using glue stick and scraping it and baking it, and it was just 50% yield. And then when we finally made the nano adhesive, that changed everything for almost every material. I'm still blown away by how well it works for everything. So this is the 120 ml bottle. There's also a 50 ml. This is 45 bucks. The other one's 19 bucks. You can get them on Amazon, but please buy direct because we don't want to give Amazon all that money, right? We make it. It's made in USA. Anyway, enough of a plug on that right now. But the point being, the guy wanted polyphenol sulfone as a material. Printing it was very difficult for the geometry of the part he had, and it was a very large part. But at the time, I didn't realize that I should have asked, what does it need to be in that material for? And it was to resist like chlorine. I think it was chlorine. But they ended up settling on ABS and buying a several $100,000 Stratasys machine because the Stratasys guys knew to ask those questions. And so the guy spent about 10 times more money than he needed to on a system to print ABS. Remember, this was only 2017. You know, had I known that, we would have secured that job. So it's important to know for us about what your material requirements are based on, right? So what kind of chemicals, radiation, what kind of environmental stresses and factors is it going to see so that we can make an appropriate suggestion or see that, hey, there's actually a better way to do this that most people don't know about yet because we're still in that adoption phase of this technology. The next category would be UV resistance. Now there's a couple reasons for UV resistance, and that can go pretty deep when you get into the research facilities out there, but most of the time it's because somebody wants to put a part outside and leave it there for years. So different materials have different qualities, and some of them are really good, but they break down under UV light. So if it's getting hit by the sun, it's going to break down in a number of months or years and going to fail, versus other materials can do great in UV, and it's like no big deal, no problem. Leave it outside for a decade, you won't even notice a difference. The next main topic is mechanical strength. And this one's kind of interesting because there's a lot of ways it can go. When you send us your part, it helps us to know what type of forces it's going to take. For example, if it's a tray that's going to hold surgical tools in a operating room and it's made out of an autoclavable material like PPSU, then, well, it doesn't really need to have much mechanical strength. It's going to sit there with stuff sitting on it. Great. Now, if it's a bracket that's going to hold an alternator inside an engine bay at 150 Celsius, well, then that's going to be different, right? Maybe it's a bracket that's going to hold a payload on a drone, and it's going to see forces twisting and forward and back and left and right and like in every direction. Okay, well, that's a different situation than a bracket for an alternator, right? You got all these different variables. Okay, so how strong does it need to be? A lot of the engineers out there are going to be like, I designed a part for this material, which has a tensile strength of 4,500 megapascals. So whatever material it's in needs to be 4,500 megapascals or better. But in 3D printing, this doesn't always apply, because remember, you've got Z layers, right? Now this is changing with the non-planar slicing and the multi-axis slicing that we've got enabled on our 22 IDEX, but not all printers have that, and it's still an emerging technology. So over the years, this will be less of an issue. But right now, for the most part, you've got layers in any given part. And those layers are the weak spot, right? Say I print this water bottle straight up, I'm gonna be able to break it that way easier than like pulling it apart, right? So the X and the Y axes are the strongest because you have straight lines of material, but then where the lines of material are joined, usually that's a weaker weld. It's a weaker bond strength, so you get anywhere from 40 to 60 to 70% strength in that axis. Now, a lot of this can be tuned in. We can dial it in. If you want us in our print service to like make it as strong as possible, we've developed ways to get much closer to that isotropic strength, but it's not always possible. So the directions, the forces, the torsion, is it shear forces? What are we dealing with? What's your part actually need to deal with? Because it's not as simple as, well, as long as it's made in this material, it'll be strong enough when it comes to FDM 3D printing. Now, SLS and SLA are a little bit different in this regard in that the strengths are often closer to isotropic in those technologies. Just not so with fused filament fabrication, or FFF/FDM. So when it comes down to it, we need to know what's happening to the part so that we can make the best decision in orienting it with the layer lines, right? So if, maybe we can just print it flat on the bed, but maybe that's going to be weak in the angle you need it strong. So it needs to be printed upright. or maybe at an angle, or maybe on this edge, right? Like if you have a part and it needs to be printed in on this edge so that it's strong that way, as opposed to being printed that way so that you can just snap it in half. That's something to consider. Now, the orientation makes a big difference in surface finish also, but we'll get to that in just a second. Actually, no, we'll get to that right now. The next category is surface quality. Depending on the orientation at which it's printed, generally top surfaces look better in FDM than bottom surfaces. Sometimes it's equal, but sometimes you have to use support material, and usually that looks a little bit worse. With breakaway or soluble support, it can be better, but it's usually not quite as fine as the top surface of any object. So surface quality is an interesting one, right? FDM is well known for having layer lines. Now you can print at very fine layer lines and have very almost invisible layer lines, or if you're printing with the right material, like a lot of carbon fiber or glass filled filaments, then a lot of times you can't really even see the layer lines. So once we've determined, the thermal, chemical, the strength, the mechanical loads, everything else, we're like, all right, we've determined the best way to print it to meet the application needs is in this orientation. And then they'll come back and be like, but I need that bottom surface to be perfectly smooth. All right, well, let's talk about that. In FDM, most of these thermoplastics, especially the high temp ones, can be post-processed. They can be post-machined, they can be sanded, they can be painted, coated, epoxied. There's a lot of ways to get a beautiful surface finish on an FDM part. So one of the things we need you to let us know is what surfaces on this need to be beautiful or pretty or smooth or quality or just untouched. Are you able to do post-processing like sanding or finishing the part after? Now, if this is a bracket in an engine bay, you're probably going to be like, I don't care what it looks like as long as it's strong. Now, if it's a cap for some sort of radio device or something, or maybe it's an enclosure for some sort of electronics going into the field, and you want that to look nice, and you should let us know that, hey, this is what the product is, this is where it's going, and we'd like it to be nice, we'd like it to look good, So that's a huge thing. Now, some people say, hey, we need a Class A surface or a Class 1, surface finish, and it's like, okay, great. Here's the limitations of FDM. Here's how we could achieve that surface finish. But are you willing to do that? Is this technology going to work out for you, or do we need to look at something else? These are all things to consider as we go into the process. There's even some ways to do like vibratory tumbling or vapor smoothing. There's a lot of new technologies coming out recently as well that allows us to take those parts, even FDM with heavy layer lines, and turn it into a part that looks injection molded. So it just depends on what your needs are, but it's something that we need to understand, and understand what your expectations are going to be. Some people don't know what 3D printed parts look like at all, let alone FDM, SLA, or SLS. They're just like, yeah, it's a part, right? Well, there's a lot of different ways to make your part look not FDM 3D printed, but maybe you don't care and we can just send it straight off the printer and that'll be good enough. Depends, but consider these things and let us know. Now, another mention on surface quality is air and watertight parts. FDM, being extruded lines, is known for having gaps between those lines and all the extrusions. Usually it's going to have little pockets throughout the part and the inside of the part, and there are, a lot of the times, if you just print a cup on a standard 3D printer, generally it's not going to hold water. Unless you really beef up the number of layers, the bottom layers, the solidity, etc. And then, we've developed ways to over extrude and increase the flow rate to really pack the material in there. And we have created hydraulically stable parts at up to 1300 PSI. It's like a coupler that will hold that amount of pressure, watertight, no big deal, works great. There's ways to do it. If you're using the standard profile on any random machine, no, it's probably not going to be airtight. But again, this is something you should let us know if you need that. Now, this is also something that's going to be heavily affected as we see more of the non-planar and 5-axis slicing, because that allows the head to print in curved surfaces. So instead of getting a large stair-stepped part, it actually is a smooth, very beautiful surface finish. And again, that's something our 22 IDEX has the capabilities built in for, and I should probably mention the 22 IDEX is our main workhorse for our print service. So if you want your own 22 IDEX, because maybe we're expensive, I will say we're not the cheapest in town, but we take relationships and making the part correctly for you very seriously, and that comes with a little added cost. But if you value that, it's more than worth it. But maybe it's too much and you want to get your own machine so you're actually seeing that massive ROI that 3D printing can provide. Consider a 22 IDEX machine. Very robust, very awesome. Plenty of other content on this YouTube channel and on our website. Go ahead and go visit that out, or give us a call, shoot us an email if you want to learn more. Moving right along, the surface quality, the mechanical strength, the thermal resistance, all these things, if it's designed in a way that makes it difficult for the manufacturing process, then it's going to be a challenge, and it's probably just not going to work. So we see this in any kind of manufacturing. You see it in CNC, sheet metal bending, literally any process. There's injection molding. There's certain elements that you need in the design of the part to make it efficiently producible. Now, we run into a thing here where people are sending their part that's going to be CNC'd or it's going to be injection molded, and they want a sample of that part for fit and fitment, a prototype done on a 3D printer, exactly as it will be done on the injection molding. And this can be kind of difficult sometimes because they're not always conducive to being done on an FDM machine. So, the same as any other manufacturing process, there's certain elements that make a part very easily produced on an FDM machine. So let's get into what a couple of those things might be, and this is something that we will consult you on if you have a part in with us and we want you to modify it to make it better. We'll actually tell you exactly what we think you should do. But in general, there's things like overhangs. If you have a part that goes straight up and over and then goes out like this, and there's no real reason for it, the part is going to have a ton of support material in this area, where it doesn't necessarily have to have support material. If you just connect this one all the way down to the center spline, boom, then the whole thing can print and print straight up. It's going to be faster to print, it's going to be cheaper to print, it's going to be stronger, it's going to have better surface finish because you don't have to switch from support over to other things, and there's little artifacts that can happen on some parts when you do that. So trying your best to eliminate 90-degree overhangs in favor of 45 degrees or more is a big advantage in FDM prints. Now, this also comes down to if you can chamfer the edges. Like if you have the bottom of this bottle that you're printing on the plate, if you can throw in a little 45-degree chamfer, like a millimeter or two, like very, very, very small, it'll make the part look a lot better right off the bat. It eliminates things that might occur like elephant's foot and things of that nature that'll give you a little lip, and it'll just make it a nice, clean edge. And then when we take the part off of the plate, assuming we don't just bend the plate to get it off, if we have to scrape it off, maybe it's a big part, then it eliminates any scraping marks or little marring or burrs that might be present on that bottom edge. So just adding a little chamfer can be a huge deal. So same thing for the top surfaces. Adding a 2 to 5 millimeter fillet on your top edges will make the part look more beautiful straight off the machine. It'll just make it look more refined and be a little smoother. Maybe you want a hard edge, and that's fine, but if you don't, it's a beautiful part, throw a little fillet on there. Easy. Now, that being said, in FDM, parts really need at least one small flat spot on a part to stick to the flat bed. This is where you start the print and it builds from it, but that part needs to be stuck to the bed. So if you send us a sphere, then the entire model is going to have to be printed with support material. And this goes back to surface quality, where the stuff that's touching and connected with that support material, almost always, I won't say always, because sometimes it works, but basically every time that bottom surface that's connected with the support material, whether it's soluble breakaway or just the same material, is going to be a little rougher. It's going to be a little nastier. It's not going to be as smooth and beautiful as the top surface. So just know that. If anything is supported by supports, it's going to be a rougher surface finish. So including at least one flat spot on your part with adhering to the bed in mind, it's really crucial for getting a great and efficient part. Now, all of these factors affect the price of the part, the difficulty, the expected failure rate, just is it going to come off the bed mid-print unexpectedly? It's happened. It could happen. All these things are factored into the pricing of your part. So the more efficiently you design it, it's going to be cheaper. because it's easier to do. So it's going to take less time, and voila. Now, the next thing to understand in DFAM, in designing for additive, is specifically for FDM, small detailed features. You can do very small details on an FDM part, but usually it's going to be like a textured surface, right? So if you want a fine texture around a cylinder or something like that, we can do that, no problem. It'll come out actually pretty good. But if you want a serial number at size 6 font on the base of your part, and those letters are significantly smaller than the orifice of the nozzle that's printing the plastic, there's no way that those tiny little details are going to come out. So if you do need a serial number on your part, then we can definitely do that. It just has to be a certain size to be legible or to even look like letters, right? As opposed to little blobs of plastic, right? So you can even do it in multi-color so that the serial number is in a different color from the actual main part. That's pretty cool. But neither here nor there, there's a limitation to the details that you can have on a part. Now, if you wanted to do that and have size 6 font with the whole part name and your logo and everything on an area of the part, maybe it can apply to a different 3D printing technology like SLA or SLS. Both SLA and SLS do phenomenally well with super fine details. They're just a totally different technology, and they excel at getting very small features that are just come out perfect. Like, it's pretty incredible what you can do with those. One last little thing on the support material. You know, one thing that some of our best customers love doing that they've learned works great is actually designing in sacrificial supports into the 3D model they send us. So instead of relying on the slicer to support this overhang and just put support material wherever it thinks it needs it, you can actually design supports in CAD so that those print up, design the part perfectly just in the spots you need, and then we don't have to use supports at all. It just prints as one thing, and you break them right off at the end, and that works fantastic. So that's another design element that you can choose to include with your part that you send us. Really, at the end of the day, a couple small tweaks can make a part 100 times better for FDM 3D printing. Very low effort, very high reward. Now, if the design is final and it's a prototype and it's going to be made in another process, that's fine. We can always work with that. All right, let's go to the next section, dimensional accuracy and machining. Dimensional accuracy is one of those cool things about 3D printers. They're reliable and accurate to an extent most of the time, but they're consistently accurate and consistently inaccurate. Remember, we're squeezing plastic through a nozzle here, liquid plastic through an orifice. It's not going to be super precision in every different dimension every single time. There's limits. A lot of the time, we can actually nail specs dead nuts on, like perfectly, really well, and it's like fresh, perfect off the printer. Sometimes though, you might want to consider post-machining. Now usually this will come around to like tiny holes, right? Maybe you got little bolt holes or holes for needles in some lab prints, things like that. There's a limit on how small and accurate the hole can be that we can print. So what we recommend is actually post-drilling those, whether with a drill press or a hand drill or anything like that. You can simply drill out holes. You do want to design them in the part so that that area has the extra perimeters and extra material to work with, but it's much better and you'll get a cleaner, super precise hole just by drilling. You can also add pilot marks and things like that to just drill in the right places. Another common application we see is lapping surfaces. So basically sanding surfaces flat to get perfectly smooth finishes and things like that. Or in the high temp parts, in the high temp materials, one of the beauties is that you can actually machine it. Now, a lot of plastics you can't put into a CNC because the spinning, or if you've ever tried to drill into ABS with a high-speed drill, you know it melts and does all kinds of crazy stuff you don't want it to do. But with the high temperature materials like PEEK, ULTEM, PPSU, they're high enough temperature that you can actually hit that with a CNC and be just fine. So this opens a lot of possibilities in that you could print a net shape part. You could even use like a 0.8 nozzle and 0.4 layer heights and print the part 4 to 8 times faster, and then throw that on the CNC and give it its perfect outer diameter surface, or maybe just whatever it needs. You can print the net shape part and machine it to perfection and save a lot of time and still get those tolerances dialed in. And again, the beauty of 3D printing is that you can run that file over and over and over and over, and it will be consistent and the same every time. So that's really a benefit. Now, if you're doing aerospace parts that need to be certified, you might need to get like CT scanning or something like that to verify the internal of the part is consistent and good. If you need that, just let us know. Next section, part size and build volume. The real big thing, the big takeaway here is if your part's too big for our printer, then there's some other ways to go about printing it, because we can't print the whole thing at once. Obviously, it won't even fit in the machine. So instead, we can cut it into pieces. Now, there's a couple ways to do this. We could just do a flat cut, and then you could glue it together. You could sonic weld it together. You could use chemical welding. There's different ways to do it depending on the geometry. Is it a big flat surface, or maybe it's two thin walls going together, super glue? I mean, depending what you're making, there's a lot of ways to adhere parts together. You can also mechanically design it to mount together with like dovetail type fittings, and there's actually a feature in Prusa to do this. So if you got a part, you could literally slice it right there and have two parts that will mechanically mate together. And so that's an option. Now, there's a really great example of this happening right now, and that is Mike Lake, the YouTuber. He is printing the entire body of a Porsche 911 GT3 RS, and he's doing it on a tiny printer. He's doing it all in sections that big. So the full bumper, the quarter panels, everything, the hood. Definitely go check out that YouTube channel. He's doing some really neat things with 3D printing and cars. The next thing to talk about is sort of special requirements for parts. Now, this can be food safe or sterilization, or it needs to, be in constant human contact, being biocompatible, different things like that. These are all important things to note. Also, regulatory requirements. There's certified grades of material, and there's just regular grades of material that you can buy off Amazon or whatever. But if you need traceability, it's like a certified material it's been tested and analyzed, and it's exactly what it needs to be. This is usually like aerospace or medical applications. Then, well, we can get that, but you need to specify that, because not all filament is made the same. USP Class 6 is, a material might be USP Class 6, but if it's not certified, it's never getting passed by the FDA. Another big thing we see is COCs, COAs, and traceability. Having the ability to look at your spool, see the lot number, and then go to the manufacturer and say, I need to know where this original raw material came from, when it was produced, what batch that was, all these things. That is something we provide in all the materials that we sell, because, well, we mostly sell to high-end companies, and they request that a lot. So if you need that, that's definitely something we can provide, but you need to let us know at the beginning of the process. And then, of course, food safe is its own thing. A lot of the times FDM is sort of hated on for its porous nature, and that those tiny little layer lines and little gaps and stuff can take bacteria, and then it might not be good, and dishwasher might not clean it out. Autoclave will usually do the trick, but yeah, food safe is definitely something to consider. There's a lot of food safe materials, but it's not always as simple as just being a food safe material. The design and the manufacturing process does make a difference. All right, next we're going to talk about file formats and file readiness. Now, this really ties in with DFAM, design for additive, right? The design of the part being ready for the printer. Now, usually we don't see much issue here, but sometimes people send a part that's not a solid watertight part. It's an STL, but it's got a hole, so it's not interpreted by the computer as being solid, and that either needs to be repaired. Sometimes we can take care of that, but usually it's a design mistake, or it's just designed improperly, and so we'll send it back and say, hey, you guys need to fix this. So making sure that your parts are watertight and solid bodies is also important. Now, as far as files goes, we love step files, STP files, STLs, OBJs, 3MFs. We can work with all of those. Now, sometimes you'll also have edges or non-manifold edges and things like that are errors in the file, or like duplicate faces and things like that. All that does need to be adjusted. Otherwise, you start seeing really weird artifacts in the 3D printer slicers and the toolhead preparation. It can be strange. So if we see that, we'll always send it back and say, hey, this is what it's doing. Send us a better file, yada, yada. But if you can check that before sending it, that's always great. And of course, readiness Also includes DFAM, has the part been modified slightly to work well with the manufacturing process? Have you added a small flat spot? Have you added chamfers on the bottom edges or fillets on the top edges or anything like that? And this is something we do a lot of heavy consulting in. So if you are wondering, oh, I don't really know what I need to do to make this work on those machines, just give us a call, shoot us an email. Sometimes we'll just do it for free. Give us a call, be like, yeah, you're gonna okay, change this, change that thing, and let us know. And if you want like a real deep consultation, we actually have packages for that too. So give us a call, shoot us an email. We are here to help. And one last topic on the file preparation, we do receive a good amount of NDAs. On our 3D printing service submission form, there is a checkbox saying, I need an NDA, and you do not need to upload files at that time. If that's you, go ahead and check that. We'll reach out with our mutual two-way NDA, and we'll get that set up before you send any files over. So NDAs, also a big thing. There's a lot of cool products out there people don't want other people seeing, and we respect and value that. Lastly, let's talk a little bit about budget and lead time. We understand that a lot of times you don't want to tell us that, hey, I need to get this part for, $35 or less, or it needs to be under $1,200, whatever the case may be, because then we could just be like, all right, it's $1,100. Believe me, I get it. But if you know that you need to get this part under a certain budget range, then, dude, it helps us so much if you just tell us sort of what that range is, or better yet, specifically, I'm currently getting this part for $35. If you could do it for less, I'll buy it from you. Then we can just quickly see, hey, is that even possible? Let's see. And sometimes, no, dude, you're getting a great deal. Keep doing it. Or it'll be like, oh, dude, we can make that for $3. Like, no big deal. If you had your own machine, it would be $3. We're going to have to charge for our labor and our time. But you see what we're doing here? We're here to help and consult and whatnot. So the more information you can provide, the better. Peak parts in particular, I've seen them go from $1,400 per part, really complex little medical device part, goes inside a medical device. Not even that complex. And they were previously machining it. So they'd buy a block of PEEK for $300 and they'd machine it on a Swiss, CNC machine for another, $800. And overall it was $1,400 per part. We printed it in 3 hours for $14 in raw material. ROI? Oh my gosh. High temp parts have ridiculous ROI because these materials have been used for 40 plus years, and the way they're being made is so much less efficient than 3D printing. And that's why we're here, guys. This 3D printing service for high temp here at Vision Miner, this is our bread and butter. This is what we've been doing since 2016 and beyond. Wait, it's 2016 and beyond? The high temp stuff is our main focus, and the amount of money and time that companies are saving is just incredible. So, sorry, I still get a little bit excited about that. It's ridiculous. It's insane. It's changing the face of manufacturing. The world of manufacturing will never be the same. And then, of course, lead time. When do you need it by? Do you need it in a month? Do you need it next week? Do you need it 3 days ago and you're trying to get anything as fast as you possibly can to make this work so that your project doesn't fall apart? Okay, let us know that too. It helps us to know, hey, well, this guy doesn't need it for 3 weeks. We can get it to him easily in 2 weeks. We'll fit it into the queue and slot it out and have it done with time to spare, no big deal. Or this guy needs a rush job. All right, well, we're gonna have to charge for it, but drop everything and we'll get this thing done over the weekend for you. Depends where you're at, what you need, but let us know. What kind of deadlines are we on? Is this a multi-stage thing? Maybe you're getting 3 samples and that's gonna be followed up by 10 samples. If the investors, like the results, and that'll be followed up by an order for 100,000 or maybe just, 10 machines so you can produce them yourself, and we'll teach you how to do that. It is interesting. As a company that manufactures and sells 3D printers, having a print service, a lot of the time we will tell you, hey, if you just bought a machine, it would pay for itself in a matter of months, if not weeks, if you were doing it yourself. But that's some people, not everyone, and that's why we do have this print service. So other than that, those are all the main things that we need to know from you if you've submitted a part on our print service. All of these things will help us be more efficient and faster and more affordably, getting you the best part possible. So if you've already submitted a part, then try to watch back through this and answer as many of these questions as you can. Shoot us another email, or we'll be calling in the next few hours or whatnot to ask these same questions. But chances are you're on the forum page right now. Who knows? Maybe you're on YouTube. If you're on YouTube, leave a shout out down in the comments and give it a like. Anyway, guys, thank you so much for watching. Have a positive rest of your day, and I will see you on the next one. Dude, that was gonna be a 5-minute video. Now it's like everything you need to know about our print service video.
Well, that could